So last in this section we want to talk about is figuring out the number of positive divisors a number has. So we might ask, how many positive divisors does 24 have? Not just how many prime divisors, but the total number of divisors. 24 is divisible by 1, 2, 3, 4, 6, 8, 12, and 24. Something you should notice about these divisors is that they pair up because 1 times 24 gives us 24. So since 1 is a divisor of 24, 24 is also a divisor of 24. Since 2 is a divisor of 24, 24 divided by 2, or 12, is a divisor of 24, because 2 times 12 is 24. Since 3 divides 24, when we divide 24 by 3, 8 is also a divisor of 24. We can also think because 3 times 8 is 24. And lastly, because 4 is a divisor of 24, then 24 divided by 4, or 6, is also a divisor of 4. Another way we can figure out the number of positive divisors of a number is to think about its prime factorization. So if I want to figure out how many positive divisors 24 has, I would first find the prime factorization of 24, which is 2 cubed times 3. Notice that 2 cubed, which is 8, has 4 divisors, and 3 has 2 divisors. So we can use what's called the fundamental counting principle to determine that there are 4 times 2, or 8, divisors of 24. We can see this because we have the divisors of 2 cubed are 1, 2, 4, and 8. The divisors of 3 to the first power, or just 3, are 1 and 3. And then we find the number of ways to combine a divisor of 2 cubed and a divisor of 3, and that is going to be 4 possible choices for 2 cubed, 2 possible choices for 3, and we say 4 times 2 is 8 possible ways to find a divisor of 24. We can formalize this principle by saying if P and Q are different primes, M and N are whole numbers, then P to the N power, Q to the M power has N plus 1 times M plus 1 whole number divisors. So, in general, if P1, 2, and up to Pk are all different primes, and N1, N2, up to Nk are all whole numbers that are their exponents, then we have P1 to the N1 power times P2 to the N2 power, all the way up to Pk to the Nk power. That will have N1 plus 1 times N2 plus 1, all the way up to Nk plus 1 whole number divisors. And the reason it's plus 1 is because, again, remember if I had 2 cubed, the divisors of 2 cubed were 2, 2 squared, 2 cubed. So that's our N, but also just 1, or 2 to the 0 power. So that's plus 1. Let's use this principle to find the number of positive divisors of 1 million. First, I need to determine the prime factorization of 1 million. So I know that 1 million is a power of 10 because I have just a bunch of zeros and a 1. So remembering that the first place value is 10 to the 0 power, the next place value is 10 to the 1 power, 10 to the second power, 10 to the third power, 10 to the fourth power, 10 to the fifth power, and this is our 10 to the sixth power place value. So I know that 1 million is equal to 10 to the sixth power. Now I just need to split up 10 into prime factors. So I know that 10 is equal to 2 times 5. So 10 to the sixth power is equal to 2 times 5 to the 6th power. And using the properties of exponents we've learned, I know that that will be 2 to the 6th power times 5 to the 6th power. So that is our prime factorization of 1 million. 2 to the 6th power times 5 to the 6th power. So we notice that 2 to the 6th power has 7 divisors, and 5 to the 6th power has also 7 divisors, because 2 to the 6th power is divisible by 2, 2 to the 2nd power, 2 to the 3rd power, 2 to the 4th power, 2 to the 5th power, 2 to the 6th power, and 1. So that's 7 divisors, and same goes for 5 to the 6th power. So to figure out how many divisors 1 million has, I'm going to take 6 plus 1 times 6 plus 1, or 7 times 7, and see that 2 to the 6th power times 5 to the 6th power has 49 divisors. So 1 million has 49 divisors. All right, so what if we wanted to find the number of divisors of 210 to the 10th power? So in the same way, I need to find the prime factorization of 210 to the 10th power. I can do this by finding the prime factorization of 210. So 210 is divisible by 21 and 10. 21 times 10 is 210. And I can split those into their prime factors. 21 is 3 times 7, and 10 is 2 times 5. So 210 is 21 times 10, or 2 times 3 times 5 times 7. This is all still within the power of 10 that we originally had for 210. So using the properties of exponents, I know that this will be equal to 2 to the 10th power times 3 to the 10th power times 5 to the 10th power times 7 to the 10th power. 2 to the 10th power has 11 divisors because we add 1 to 10. Same for 3 to the 10th power, 5 to the 10th power, and 7 to the 10th power. They all have 11 divisors each. So I would take 11 times 11 times 11 times 11, which is 14,641 divisors. So 210 to the 10th power has 14,641 divisors, and that is a lot.